here we go. So Dan PERUNKO. In 2006, Dan co-founded with Gavin Healy Balance Point Home Performance, a successful full-service home performance analysis, retrofit, consulting, and training company. Dan works on new and existing construction designs and hands-on installation of enclosure, mechanical, plumbing, and indoor air quality components based on testable performance outcomes. Dan especially enjoys improving existing homes, frequently providing homeowners with levels of comfort and energy consumption that they had not believed possible. Snaps for that. All right. He is a professional trainer who designs and delivers full and multi-day courses for California's utility companies, energy training centers, and HPC national and regional conferences. Dan works towards bringing all of his experiences from construction, design, and building analysis together to make his class materials relevant, useful, and understandable regardless of the student's level of experience. So, without further ado, we have Dan!
I always feel guilty when I realize somebody's going to read one of those things.
Real quick.
Right? Like there's just this thing you have to send out so that the people that are hiring you feel like however they need to feel. And then I show up and somebody reads I'm like, oh God, why did I do that to them? So anyway, thank you very much.
No problem. Real quick, if you do need me, my e's a little small. I didn't.
Yeah, no, it's okay. If we need to do that, we'll figure it out. Okay, so for the moment, we'll just let it rest, and then we'll see what happens. I asked her to see if there was anything I could write on, because I tend to draw really bad pictures. It may or may not be necessary. So I have like 80 slides, and I'm supposed to talk for like 15 minutes, 20 minutes. So clearly that's not going to work. But there's some cool stuff in there. The foundation of this talk is we are decarbonizing the built environment, right? Because we feel like we should do that for the planet, right? And our children and all that stuff. And meanwhile, we're taking fossil fuels sort of out of the equation, which reduces the amount of carbon we're releasing into the atmosphere. And we're putting all this refrigerant into the atmosphere. And, well, we're putting all this refrigerant into systems, and it's ending up in the atmosphere. And the sort of efforts are all electrify at, all costs, right? Forget about the details. Don't tell me it's complicated. Do not make me slow down. We are going to do 1 million homes this year, right? And that never happens without casualties. So the question is, like, how bad are the casualties, right? So the refrigerants that we're just moving away from are 2,000 times more impactful than carbon, right? So if you release 1 ounce of refrigerant, that's 2,000 ounces of carbon equivalent. 1 pound of refrigerant is 1 ton of carbon equivalent. So the little jug that I carry around from service call to service call is 30 tons of carbon, right? And so that's not how anybody thinks about any of this. When I'm training a new employee and I say, hey man, the best we can do is like 1 to 3 ounces of lost refrigerant in this process, which is 2,000 to 6,000 ounces of carbon released into the atmosphere. They're like, wait, what? Right? Like it's somewhere they have that realization. And mostly those of us that are trying to do good things in the world are not thinking about any of that, right? And when I get asked, I rabble-rouse just enough to occasionally get asked to appear on some panel or some focus group or something. And I'm the only person in the room who's saying, hey, like standard installation practices are a problem and standard sort of service practices are a problem. Because everybody else thinks that HVAC contractors are either great or crooks, right? Like either they show up and cut the line set, release all the refrigerant because they, they're just bad people, right? Or they are amazing, they do an awesome job. And sort of neither of those things are really true. Like there are a few people who will cut a line set and release the refrigerant, and they're always going to be there. If you can catch one, you can pay like 1 year of your kid's tuition with the reward, right? Like it's huge fine and a huge reward. It's almost impossible to like enforce any of that, right? So this really doesn't matter. What matters is we're moving to mechanical connections for systems that operate at over 400 PSI. right? So this little funnel looking thing is pressed against a male sort of brass thing that's supposed to meet it, right? And that is supposed to be able to withstand 400 psi for years. And the people that are installing those things are not using factory manufactured parts like that. We're field manufacturing the flare. And what do you think HVAC technicians' sort of daily existence is like?
Climbing through hot attics.
What's that?
Climbing through hot attics.
Like climbing through hot attics while somebody is like, can you get to the other job? These people are yelling at me, right? Like it's never, and even for me, I try really hard and like, I do not want to work on this again, right? Like there's just this inherent problem in that whole process. And so I go out of my way to say, okay, look guys, we have to get this right. So this is our procedure. You're going to do this and this and this and that, right? And we're going to do it every time. And if it fails, we're going to do it again, right? Until we get it right. And that's not our norm at all, right? Like what the norm is, get to this place and that place, and then see if you can get back to the shop before you go on overtime, right? And so how are we going to save the planet, right? Like maybe the natural gas infrastructure is leaking so much that the thousands of pounds of stuff that has a 2,000 times multiplier is less of a problem. But I'm pretty sure my next career right before I retire will be like just fixing these things, right? Which is not fun work. I really don't want to do it. So I just want you guys to think about it. Whatever your role is, right? Whether you're an installer or a designer or a person who's involved in rebates or programs or whatever, like we should be paying a huge amount of attention to this little piece, and nothing in sort of American culture is really set up for us to pay attention to detail and slow down, right? So it's probably going to fail. I'm probably wasting my time. But anyway, you guys seem like you wanted to listen. So stuff. There's all this stuff out there in the world to try to make this process a little better, so you get to play with a little bit of it. What's that?
What's that one?
This is part of this. This is a flaring tool. And so there's all these flaring tools on the market, and I've used a whole bunch of them. And I really think this or its peer, when there becomes a peer, is really the only thing we should ever use. Because you don't have to be good at anything to do this. It's standardized, right? And we already, everybody's comfortable with the idea that even the talented technicians they have a monkey on their back named Tony who needs them to be somewhere else, right? Like, so nobody is really slowing down. There can't be any art in any of this, right? Like this has to just be like factory work, right? So this has got a little stopper, and you put it together like that, and then you plug it into there, and it grabs it, and you just push a button, and it makes a flare. So
Don't forget your collar though.
this, I didn't put the nut on there. I didn't bring any of those. This actually looks way better than I thought it was gonna. So what I didn't do was cut the burr out of the inside of the pipe. So there is still a little bit of skill required, right? Because when we cut pipes, we're sort of bending the copper at the same time, which is what this little thing is called. So it's a deburring tool or a burr whip. I had one female employee in recent history, and she called it a burr whip, which I just thought was cool as shit. So this is a burr whip. Right? So you can imagine, right? I'm trying to make press compression fitting, right? So all I got to do is roll my wrist, and I make a divot in this. That'll get so this is the artsy part that's really hard to get away from, right? But if you can deburr properly.
There are some deburring tools you can get right there.
Yes, there are deburring tools, and I am not that smart and dyslexic and have hit my head a lot of times. So those tools for me have never worked. but they might work awesome for you. So like that's the thing where it becomes like you have to find the tool that is really the best tool for you. And so I would leave those sort of on the table. I just don't use them.
What's that one called?
This is a NAVAC flaring tool. And right now, since they're the only one, if you just search NAVAC flaring tool, you'll find this. It's not even that much money. It's like $400, $300, something like that. So there you go. So here's one I deburred, and there's one I didn't deburr. And honestly, the one I didn't deburr looks better. So I don't know. So it's tricky, right? Like this, and this is what we have to be able to. So if you have a goal of putting in 1 million heat pumps and you want them to be variable capacity, mini split, high efficiency heat pumps, whether they're wall heads or ducted or whatever, that means that 4 million times this has to happen correctly at a minimum, right? Because there's 2 on the outside and 2 on the inside. So this is a huge deal. So there's parts, like while I'm talking, play, right? Like try it. If you break it, whatever, I'll get another one. I don't think you can, so don't worry about it a ton. The way it works is you put the pipe in here against the stop, right? And set the depth so you're just sort of gently pushing on the stopper, right? And then the pipe sticks outward from the tool and clamp it together and push the button, right? So knock yourselves out, have fun with that. And then somewhere floating around is the factory flare on something that looks kind of like this. Where did that end up? So
Nice flare.
it is pretty nice, but it's got like a weird little rim on the outside.
Yeah.
I think that's probably okay,
It
right?
just seems so thick.
It is thicker material, which makes me feel better, right? Like maybe
It wouldn't like smush.
Well, maybe it won't smush enough, but I have also like, I'm saying like a lot today. Maybe it's because I had a beer before I started this talk. I have also over torqued the fittings and had them just break off, right? So the thickness of the pipe is kind of nice in this instance. So then the question is like, can you do better than this, right? Because this is what a factory will do for us. But then it has this whole other problem, which is this side of this setup is relying on O-rings, right? So there's like a rubber synthetic compression fitting, which is super tempting, right? I don't have to be responsible for this now. All I have to do is put this together, and then there's a like a $3,000 tool that compresses this, so that, right? And so I actually, what's that?
You get 2 on yours.
Well, so not all the refrigerant companies that make these fittings are doing this with the 2 rings. So I have avoided the ProPress tool because it's really expensive and I'm really close to retirement. Like I'm going to retire and I am going to have like a tractor trailer full of really expensive stuff, right? Like what am I going to do with all this crap? So I didn't want to buy another thing. I was doing a plumbing job and I just couldn't sweat the pipe. It was underground and it was running water, and so I hung my head and I went and I bought the ProPress tool and finished the job, which was great because then I got paid and I got to go home. The woman at that plumbing store is great because I'm not a plumber and she knows like everything about everything. Her family owns a store. I presume she grew up there. So I just walk in and I say, hey Lexi, I don't do pressure blow off fittings so in vacation homes in Truckee, when you shut the water off, the reduction in water pressure drains the entire plumbing system into the basement, into the crawl space. So the crawl space just floods, but your pipes aren't full of water anymore. So the cold water lines in Tahoe houses all drain like waste lines to these little spring-loaded valves, right? And so I don't work on stuff like that. It's a ridiculous idea. We're spraying water in the crawl space.
What is that called?
I don't remember, but I can help you figure it out. So I'll go in and I'll say, Lexi, I got to replace one of these. And she's just like, idiot. And then she takes me wherever and she shows me the thing. So I said, Lexi, I got to buy this stupid tool that I don't want. And she said, they make refrigerant fittings now. And then she like gave me a whole dissertation on good fittings and bad fittings. It was great. And so because of her, I found these, where at least this manufacturer's trying, right? So we're going to have a crimp fitting that's supposed to be able to withstand 400 or 500 PSI. But I think actually all this stuff is supposed to be rated for 600 PSI. And I mean, how many of you think an O-ring is going to work at 600 PSI for any kind of time? Right? Like I just have a hard time believing that, which is why I haven't been willing to go down this road. And then she showed me these. And so I haven't tested these yet. I don't know what I think, but I'm hopeful. Like maybe this is a good idea. So I don't know, test it. And so what I think tested is build a little loop and put it under 600 PSI of nitrogen and then like leave it underwater for a month and see what happens, right? Do you ever see bubbles? Does the pressure go down? I don't know. How do you think we should test it? Right? Like we put these things out in the world and hope that the environment's going to be okay. So that's the other thing about all this.
Thermal cycling too. The components, thermal cycling is not only pressure, but they're like a...
Right, they're changing, yeah, because they do. They go from, it's not crazy, well, no, it's pretty big. So it might be like 120, 140 degrees on the hot side, all the way down to, especially if there's been a refrigerant leak, like 22 degrees on the cold side. So that's a pretty big delta. So I've been doing this since 2007, and I've had a pressure regulator that I bought in 2007, and it's great. It works awesome, and I've really not wanted to replace it. Got to retire. Don't want more crap. But it only goes to 500 PSI, and I finally broke it. And so I just spent, I don't know, $200 on this thing. This thing says it'll go to 800 PSI, right? So we should be able to like really stress test things. And the field testing for refrigerant systems, depending on the manufacturer, is potentially supposed to be at 600 PSI, right? So a whole bunch of the standard tools that we've been using forever just won't even do it. And so this is stuff that might go in your plan set, right? Line set, to pass vacuum under these conditions. Line set to pass nitrogen testing under these conditions. Because the manufacturers, what do the manufacturers want? Just sell a lot of things, right? So Gavin, my retired business partner, went to a conference in, I don't know where it was, someplace in South or Central America, and he got a little VRBO, and he went to these meetings every day, and he had a great time. And he went to the grocery store to buy food, and he checked out the mini split aisle and sent me pictures, right? Like you could put a mini split in your shopping cart and lease it from the grocery store, right? So the manufacturers want anybody can put it together. So like this, this whole leaking thing is actually a big international problem. So they're not going to have in print anything that's super rigorous, right? So we have to choose that if we want. So anyway, so that's why I'm here, and I have like a million slides, which I'm not even, now that I did this way, I'm not even certain I really needed the slides. Where did I put that thing? But anyway, let's see if there are a couple things in here worth showing you folks, and I'm super happy to do questions as we go if that's helpful for you. So I am a working contractor. I still, less and less, but I still do build things myself. Turns out that I can't sort of keep up with everything that needs to happen without employees, so I'm trying to get better about training and teaching other people. We do tons of heat pumps, and tons for a little company, right? Like I am not, I have a friend who has what sounds like exactly the same business. He does $5 million a year. I do $500,000 a year, right? Like, so the volume is just exponentially higher for a lot of these companies. But having said that, like we've done quite a bit. One of the things that the industry is really struggling with, well, let me rephrase that. One of the things that the industry should be struggling with is how to figure out whether things work properly without hooking gauges to them. Every time you hook a gauge setup to a refrigerant system, by definition, you have to release some refrigerant. It's impossible not to release any. And while refrigerant release is illegal, small refrigerant releases are legal because they're impossible to avoid. So what do you think the EPA's limit on how much refrigerant you can release is while you're working? There should be, there's got to be a limit, right? You know I'm setting you up. It's called de minimis, and if you look up the word de minimis, it just means not a lot. And that's it. That's the law. What?
But it's Latin.
But it's Latin, so it feels better, right? As an HVAC contractor, I'm allowed to release only as much refrigerant as I need to release, is essentially what the law says, right? And I get it. It's really like, how would you even quantify it? How would you enforce it, right? Like, it's an impossible rule. But it's also how we trained everybody. Like, it's okay, you're allowed to release a little. And then everybody's definition of a little is super different. So anyway, so there's all these questions. I did this for a group of HERS raters. And I guess I'm presuming that you guys are decarbonization people. Is that fair? Okay, so I didn't need to ask you all those questions. And the group that I did the slideshow for was in Denver area. And so I picked Denver. And I was just trying to figure out, like, how much refrigerant's out there, right? Because once again, like, we don't have great metrics in our heads for how big a problem this might be. So, there's around 1 million residential buildings. HVAC systems have around 3 pounds of refrigerant in them. And so that adds up to 132,000 tons of carbon that is potentially available for release, right? It's installed in stuff. So if those things are leaking, this is a massive problem. If they're not, it's not so bad, right? But this is one metropolitan area. So it's just kind of like scale, right? The scale is huge. And I tried to find any kind of a in-print rule from anybody about how much refrigerant you legally could release. And there is some stuff in print, and it says, like, in commercial systems, over so many tons are allowed to leak like 20% or something a year. So the numbers are actually pretty high, what's allowable. And those were like 20-ton and larger systems, so they have huge volumes of refrigerant. There's almost no rules for us. We can kind of do whatever the hell we want. And if I'm wrong about that, I would love for somebody to, like, see this posted somewhere and then email me, hey, you idiot, there's actually a rule, right? But I can't find it. It seems to me like there are, people can just do sort of whatever they think's okay.
We have to use low-loss fittings these days.
We should, do we have to?
Yeah?
I wish I brought my gauges, because this is good. Hold that thought. Low-loss fittings are super important on line set gauges, right? Because you don't release refrigerant.
And required by the EPA.
And required by the EPA, but the next step is even better. It's way at the end of the talk, so we'll just do it now. So when you have a manifold set, right, which is what all the HVAC contractors use, and this is why that first slide said we should be looking at non-invasive testing. You have this little valve body that has 3 sides, and then you have these long hoses that come off, and you connect to all the stuff, and we're supposed to use low-loss fittings so that we can connect and disconnect quickly, and then the refrigerant, and this is where the definition gets weird, low-loss fittings that are really good keep the refrigerant in the hose, as well as connect and disconnect really quickly. And so you do your service, and you use your low-loss fittings, and you disconnect the system from the gauge test equipment from the system, and then what's the next thing you do? Legally. You would never do it.
Recover from the hose.
No, nobody ever does that except for you and me, right? You release the gauge set to the atmosphere because it's inconvenient to do anything else. And if the system you were working on had water or acid or anything else, impurities in the refrigerant, it's a contamination model, right? Like, you can pollute the entire building and have all these problems because you introduced stuff from one machine to another. I don't know how bad that issue really is, but that is like what the HVAC industry believes. And there's probably some truth to it. And nobody has DC-powered recovery machines mounted in their truck, right? So you can't go back to your truck and hook your gauges up and dump that refrigerant into a bottle, which would be our ideal. So standard practice is to go through a set of steps when you disconnect, to run as much refrigerant as possible back into the machine you're working on, and then release the rest to the atmosphere. And so that release ends up being 1 to 3 ounces of refrigerant. It can be as high as 8 or 9, but it's typically 1 to 3 ounces of refrigerant sort of per service call. And so then let's do that math. So let me jump down. There you go. Okay, so this is what we just talked about. So you take one service technician working on systems that have R410A, and you send them to 5 places a day, 5 days a week, right? Because Each service call is worth $300 to $500, probably $500 to $800 now. And so this is like real money. Service is really good money. So that person releases 1 ounce of refrigerant 5 times, 5 days a week. So that's 25 ounces times 2,088 pounds divided by 2,000 pounds per ton. And that one service tech released 1.63 tons of carbon just doing service. And they didn't break any rules, they didn't break any laws, and they did as well as you can do with the sort of current tools. Right? And so how many service techs are run around Sacramento?
This is in 1 week.
Yeah, it was 1 week. One person. Right? And so maybe they only go to 4 houses, so it's only like 1 ton. Right? It's these are big numbers. So then if we go to R32, this number, right, that doesn't really work. This number goes down to like 760 or something instead of 2,088. 760 only sounds good because 2,088 is so bad, right? Like if we had not had this conversation and I showed up and said, all right, the refrigerants are 760 times worse than carbon, you'd be like, well, shit, that's not okay, right?
Yeah.
And so then there's another refrigerant that's, so the manufacturers were given like a timeline. Right now you have to get under this threshold and you can get there with R32. In a couple more years, you have to get under this other threshold and you can't get there with R32. So some of the manufacturers have jumped to the second threshold, which is R454 is the refrigerant that meets that. And it is 460 times worse than carbon or something, so significantly better than R32. R454 is a new chemical. It's really hard to get. So like my friend that has the $5 million a year business, he buys a couple $100,000 worth of stuff from one Johnstone distributor every month, right? And he bought a bunch of equipment from them and then they refused to sell him R454 because they didn't have that much and they were saving it for people in their premier program for some other brand or something. And so, like he, being smart, just called and said, you're going to lose $150,000 next month unless I get a bottle of that stuff, right? And so then they gave it to him. But that's how scarce it is right now. And that'll change. Probably 6 months from now, that'll all be eased up. But it's sort of a really weird time at the moment. So if you can find equipment that meets like airflow and performance specs and all that stuff and is using R454, you can jump like one regulation ahead. So that's certainly worth thinking about. But it doesn't make any of this stuff go away, right? The ongoing continual leakage from install issues and then service issues. Mini splits don't have any really good published service protocols. Like I did it yesterday. I have a system that I installed 7 years ago that started dripping water inside the customer's house. Dripping water almost always means that the refrigerant leaked. Like the machine is so good at adjusting itself, it will keep reducing its airflow so that it balances against how much refrigerant it has left, and it'll start blowing like 20-degree air into the house, and it'll cool itself off to below dew point, and then it just starts dripping water.
Is that true in humid and dry climate?
Yeah, this was in Grass Valley.
Oh, so you do get
And remember, it's inside the house, right? So it's 20% humidity outside and 50% humidity inside. So, and this is a passive house, so it really is airtight. So it maintains a stable amount of humidity. So anyway, they called me and was like, crap, right? Like I have one that failed, right? And that makes me feel bad. And so I went out, and sure enough, it was low refrigerant. I can't find the leak. All the fittings that I'm able to access with that sniffer don't show anything. There's no other signs of leakage. And so we're not going to gut their house, right? So I'm just going to put a sealant in it, and I won't know for another 7 years whether that worked or not. But and that's trying really hard. Like we still have some systems that have issues. And I don't remember why I went. Oh, I know. For legacy systems, right? Like the stuff that's the big cube in the yard, you use superheat and subcool to check refrigerant charge. And so the standard service call is to go out, check the capacitor, which is an electronic part, super cheap, check superheat and subcool, and replace the filter. There's no superheat and subcool for this kind of equipment. So when we cross over into like the high efficiency mini split style equipment, the service techs are not being sort of like lured to hook their gauges up. So we could sort of make that whole issue go away by, and this is horrible, right? Like if, when you put this on the internet, I'm going to be executed. Like if we stop buying all the American stuff, right? Because, and I used that equipment forever, and I think it's great. Like it's super durable, it does its job really well, the price point is good, but the service techs hook gauges up to it as a standard procedure. So either the service techs need to stop doing that, or we need to stop installing that stuff. This kind of a system, if you come back and do an annual install, you're just going to stand outside and look at it and be like, yeah, that works. Give me $50, right? Like there's really nothing to test. You change filters, you clean it, and you're done. What's that?
I have a question.
Okay.
The ACA 310 commissioning procedure, I thought had something where it's a non-invasive refrigerant.
Yes.
And does that only work for
I don't
central
know.
AC heat pump systems?
I don't know the answer to that, but anything that is a non-invasive refrigerant charge test is something we should support, right? Because you can get all of the information. All the pressure test just tells you what the condensing and boiling point temperatures are in places that are hard to reach. That's why we measure pressure. So I can find out in air conditioning what the boiling point temperature is in the machine in the attic while standing upright in the yard. And then I can find out what the condensing temperature for that vapor when it returns to the outside is. And then they give us metrics to look at those numbers and see whether they're inbounds for this equipment. You could actually have a temperature sensor mounted on the coil and just plug in a K-type thermocouple to it and get the same information, right? It's really just a temperature you're getting, but you're getting it remotely. And so we don't actually have to use this technology. It's just how we do it. And then the manufacturers have the ability to just have like an LED, LCD, some kind of screen on the outside unit that just tells you the answers, right? The equipment is instrumented almost enough already. They just would add a few sensors and you could just sort of plug your phone in and it would tell you all this stuff, right? But that adds, I don't know, $100 a machine, and that is hard in the business model. So anyway, so that's the service problem. We should do line set, plumbing, like how to do it, right? So this kind of flaring tool, my friend Mark McFarland uses these, and he puts on jeweler's glasses so he can really stare at stuff in crazy detail. His stuff is beautiful. I would let him build anything for me. But he is not normal, right? So like tools like this need to be replaced by tools like the one I gave you to play with, right? And that's just a standard refrigeration flaring tool. And it works great if you pay attention and do it right. Brazing has much better success on sort of a large scale than flares do, but all of these machines are designed to be sold or leased in grocery stores, so they can't send them out requiring braze fittings, right? So they're not gonna. So we have to get good at this. So things that matter is the HVAC tech's tools need to be really sharp, like that little white cutter that I gave you. I don't actually use for refrigerant. I have one that I don't use for anything else, so the blade stays nice and sharp. Right, so those things need to be sharp. When we do a bad job, they look like this, and so you can see the outside edge is really kind of rough, and there's a concentric ring. That's because it didn't get deburred, right? Like so that copper that got folded in got folded the rest of the way. This was a tool that I think is so freaking great. I just put it in a drill, super easy to use. It makes a flare like 60 degrees instead of 45, and then the process of putting everything together finishes the flare. I had really great luck with it. But you give it to somebody else who isn't comfortable with like things that are really hot and vibrating, that it's a mess, right? Like so I immediately stopped using this as soon as I hired help. Right? Like, okay, this is a terrible idea. And that too, right? We do everything with that. And I use it too. Like we just all do it this way. I'm still on the fence about this. This is the ProPress stuff. And ProPress is a brand. Milwaukee is what I bought. They call it Force Logic. It's the same thing, right? But see, this is one ring. And so like I've always been super skeptical about that. Maybe the 2-ring stuff will work better. That's where I think we should be going. Torque wrenches, super, super important. What was his name? There's this character in New York that does all kinds of crazy stuff. I've seen him do a talk, and the pictures of his work in the talk were welding stainless steel vent pipes together like 5 stories off the ground in Manhattan. Right? It's just like really weird. He's an engineer and an installer. Henry Gifford is his name. At one point, is that his book?
Yeah.
At one point, I think he sued LEED under the RICO statutes because they're like their buildings are not actually really any better than anybody else's, or there's no guarantee. And so he said it was racketeering, and he actually sued them. The guy's kind of nuts. The way that I heard this story, and I haven't asked him, so I don't know for certain, is that he bought a building like in Texas, and he wanted to convert it all to mini splits. And so his interview question for the HVAC contractors were, do you have a torque wrench in the van? And several of them didn't get the job because they didn't even have the tool, right? You can't put together fittings that require a certain amount of pressure without some way to measure, right? And so you've got to have a torque wrench, which sounds ridiculous. The first mini split that I did, I didn't know that. I just bought a mini split, started putting it together, and we were like, oh, that feels like 18 foot-pounds, right? And believe it or not, that one didn't leak. So, but anyway, so you got to work out a procedure, and what's really important is this part. So the manufacturers, depending on who they are, will have some pressure testing protocol. So like Goodman, Amana, those things, they don't really say, I haven't read anything recently. They didn't used to say what pressure you should test their stuff at, like in the initial part of building it. But on their label, it said pressure tested at 450 PSI. So immediately adopted 450 PSI. They can test it at 450, I can test it at 450, right? So we test all that stuff at 450. And it helped us reduce leaks a lot. And sort of in parallel with that, Mitsubishi and Fujitsu published service bulletins that said test all of our stuff at 600 PSI, right? And so this is, because I didn't have the right manifold, this is as close as I could get to 600 PSI on a bunch of tests,
That's
right?
positive?
What's that?
Positive.
Positive pressure, yeah.
Is that the nitrogen one?
Nitrogen test, yes. And I probably didn't say that. So I have a big cylinder of nitrogen, and I put a regulator like that in there, and we push the pressure up and watch it over time to see if it decays, right? If the pressure decays, we're having a problem.
I have another question.
Yeah, okay.
Does it fluctuate with temperature over the day?
Yeah, and I don't, was that Boyle's law? I don't know whose law that is, or somebody's law about pressure and temperature and gases. What's that?
PV equals nRT.
There you go. I don't even know what that means, but
Volume equals N, whatever N is times.
The
Rank
ideal,
in something or other times temperature.
the ideal gas law.
there you go. So yes, and so the manufacturers first said, when they said it's 600 PSI, they said do it for 24 hours, which is great. But what if it's got a slow leak and it's warmer when I come back to check, right? And so my friend Keith, who's way smarter than I am. Fortunately, I'm better looking, so it works out. He is really good at like building checklists and apps and tools for his crews to use to manage all this kind of stuff. And it took him a little while, but he figured out some kind of an app where they could put their initial pressure and temperatures in the morning, and they could go back the next day and put final pressures and temperatures in and see if it was a leak or not. But that, like, Keith's still the only person I know that has that, right? And so I do 30 minutes to an hour, and I watch it. And that has, I would say that 1% of the things I install leak at this point, right? Whereas before it was 10% or more. And it was insidious. It would go for years, like this one that just did 7 years. And this process has gotten refined in the last 4 or 5 years. And so like when one of these crops up, I'm like, God, it doesn't work. Oh shit, I wasn't doing this then, right? And so it's old enough that I think maybe I would catch it now, but I'm sure I'm going to be retired and somebody who's got my personal cell phone is going to call me and be like, hey, this doesn't work. I'm like, oh crap, right? So anyway, so high pressure nitrogen testing is like, if nothing else, that should be on your plans. Like all line sets must be pressure tested to 600 psi. You could put a savior, but unless specifically forbidden by the manufacturer or something, right? For at least an hour. And then if you really want it to be great, and the values need to be reported to whomever, right? For you guys to be the superintendent or, right, somebody in the chain that can report this data back. Because the techs are just doing it, nobody's checking, right? I take pictures of everything. So like when the customer calls me and says, hey man, my system doesn't work and it's 5 years down the road, do I fix it for free, right? Because if it's a leak, it could be my fault, right? Nobody expects me to fix it for free. They want me to fix it for free. Like, how do you sort that out? And so if I can go back into a file and I can say, nah, it held 500 psi or more for an hour, and it held deep vacuum, and and I know I did the torques and I did all that stuff, then I can't do any better than this, right? Like, this is just bad luck, right? But I need that to be able to navigate this and sort of know what I've left behind me.
What's this pressure tool what's it called?
So this is a pressure regulator. This one is the Victor Edge 2.0. I haven't even used it yet. I took it out of the box for you. And so this goes in a big bottle or a little bottle, just like helium balloons, right? But it's nitrogen. And one of these gauges is telling you what's in the tank, and the other is telling you how much pressure you've released out of the hose, right? And you can set it. So I haven't, retiring, don't want to buy expensive stuff. I haven't bought this yet, but I think I'll probably knuckle under and buy this year. So I've been doing bubble solution under the high pressure nitrogen to try to find leaks. It turns out it misses stuff. It's not really sensitive enough. This is a $600 to $800 tool. If you put on the headset and point the wand at your car tire, you can tell it's leaking, right? If you hold the wand in front of your eye and blink, you can hear your eyelashes move. Like, it's crazy sensitive. So if you take the joints and wet them and then listen with this, you'll find stuff that you didn't know about. So if your business model was to go try to find, like if you decide you're gonna go out and fix these things, you need something like this, like soap bubbles, and you need this tool, because otherwise, like, leaks that are ruining the systems are not going to show up. Like, they're impossible to find. So then after all that, we do vacuum, which is how we clean and test line sets. And we need to do a really low level of vacuum, and the instructions from the manufacturer will say pump it down to 500. If it stays below 1,000, you're good. And that in no way guarantees the thing's not leaking. So we try to do like down to 90 to 100, get it to stabilize, because there's an equalization period. If you were to take all the tubing in an HVAC in a heat pump system and stretch it out, like, it would be really, really long. And a bunch of the tubing is really, really small. And all this high efficiency mini split stuff only allows you to pull on that whole system from one side, right? So you're like, it's I don't know, 500 feet of tubing away from you, and you're trying to get moisture out of that piece of tubing from 500 feet away, and in the middle is all this little 1/16 of an inch tubing, right? And you've got to like try to pull through all that. So you can actually do it. It all works. What the techs frequently don't understand is they're pulling their vacuum and they get some number and it's really low and they think they've succeeded, and then they close all the valves and the number goes way the hell up, right? Because on the other side of the system, the vacuum is less established. And then the number goes back down, right? Because it's just equalizing. It's pressure moving back and forth through like all these little tubes. And when I first saw it, I was like, oh, that's just weird. right? And I figured it out, and I see even techs that have been doing this for a long time are like, I have no idea what that is, right? And so what we have to do, they need to learn that stuff, and what we need is to understand that we have to pull a really deep vacuum and then let it establish, and once it's stabilized, then you can start what's called the decay test. And the decay test, if you're doing like really great work, in 15 minutes, it can't go, it can start over 100, but it can't go over 200, right? And I don't, like, when that happens, I'm super nervous. What I really like is when I pull it down to like 90, and I set the valve to off, and it raises to like 130, and I come back in an hour or half an hour, and it's 136, right? Like it's just barely moving. And then if it's old existing equipment, it's got water and oil and stuff in it, this might take a day, right? Like it's really hard actually to do this for old systems. They may not be leaking, they're just contaminated, right? But for new equipment, this is like dead on. So if you were going to try to write this out as a rule, it would be pull vacuum on all new systems to under 200 psi equalized, or microns, sorry, 200 microns equalized, right? And then drift in 15 minutes, can't be more than 100 from there. Right? You can make this very black and white. And it sucks when your thing, like, because when these things don't fail, like if they don't pass catastrophically, it's like, whatever, right? I got to go fix this. It's when they almost pass. It's maddening, right? Like if you give them a hard limit, if it can't go up 100 and it goes up 110 in the time window, then that, I mean, whatever, if there's a leak, it's tiny, right? And what that means for the tech is that might take them a day or two to find and fix. And so the industry's super not on board, but this is sort of our reality. So that's a vacuum test. That's a micron gauge. That's what's giving you the numbers. Once you've done all that, then you can adjust the amount of refrigerant in it. And this style of equipment is all just weighing. The line set is this long, so I have to add this many pounds, right? It's just math in the instruction manual. You do the math, you add the weight. It's super easy. So whatever we decide to do, like you don't have to use my numbers, but all the people working on this should have some sort of a process, right, for what they're doing. They should have some kind of a checklist, right, provided by their employer ideally, and that needs to include pass-fail criteria. And it so often doesn't. Charge testing as part of service really should only be done as a last resort. Like we can have mechanical problems, we can have airflow problems, right? Like, and so that's just a cultural thing in the industry. And then the tools we use can help. Like that whole thing about releasing refrigerant from gauges. The hoses on my gauges are 6 feet long, right? So it's 1/4 inch tubing, 6 foot long, and it's full of refrigerant at 100 PSI, right? So this gauge is a digital gauge that Bluetooths to your phone, and its tube is like 2 inches long, right? So if you vent that whole gauge, it releases way less refrigerant. So this kind of stuff is slowly sort of catching on. The PG&E tool lending library actually has this stuff to lend out now, which is kind of cool. These are core removal tools, so you can open the line set up fully without releasing any refrigerant to make it easier to work on. Techs are pretty on it about that stuff. These are core depressor tubes. Most of the techs just go up to an operating machine and spin their hose fitting onto it real fast because they don't want to get frostbite on their fingers. Right? This allows you to put everything together, and then twist a little knob, and it makes the connection. Right? So nothing squirts out on your hands or into the atmosphere. These low-loss fittings are super not popular. I don't know why. I love them. I have 10 of them. Did you want to take a picture? Okay. These are the kind you and I were talking about, right? This is a back seating fitting that's on the hose, so that I unhook the hose and the refrigerant doesn't dump into the atmosphere. And then theoretically, I can recover that refrigerant using a machine called a recovery machine and put it in a tank. I don't have to release it. Just super uncommon. So the other thing is maybe we're just gonna fail at this, right? Like maybe there's no way to get the thousands of people out there in the world who are living hectic lives and it's a freaking 100 degrees out, right, to care about everything that I just said. So maybe we should just punt, right? Start buying packaged things. Like how many times in your life has your refrigerator run out of refrigerant? It's a heat pump, really. It's just one direction, right? So we could stop doing this, right? And which is a little sad because that equipment is so good. Like it works, it's cheap, its efficiency is really high. Like those things rock, right? They just leak refrigerant like mad. So maybe what we should start doing is package systems where somebody in a factory builds and tests, and the factory people really hate warranty stuff, right? Like so they're able to build things with a really high degree of rigor because that's what they do, just in this one clean spot. They do this one thing, right? Whereas we're in crawl spaces and attics and the neighbors yelling at us and whatever it is. So we could use packaged refrigerant systems and send water back and forth, right? So there's a company called Apollo that makes those, and Chiltrex makes them, Space Pack makes them, whichever one of those makes high velocity duct systems, I think that makes sense to stay away from. Those things are, I think, not good. But the rest of their stuff I think is amazing, right? And we can do all of this with chilled water, or we could. It's expensive and not common, but maybe it's the only path. So anyway, that was a lot of slides and not a lot of time. And so I'm not going anywhere. We can do whatever you guys want.
I have a question.
Sure.
If I heard it right, that high pressure, high velocity ducts aren't really ideal.
Oh, I think it's a horrible idea.
What's your take on that?
I think that, well, so they have like I've never been able to find any performance data or third-party testing or anything that wasn't like them just saying you should buy our stuff, right? And so I can find all kinds of research about the impacts of velocity in a duct in an attic, right? And how that impacts thermal losses. And we can do a whole nother talk about duct systems and how to build duct systems that have very, very low thermal losses. And so the way to talk about it is delivered capacity. So delivered capacity from the air handler or the heat pump, which is consuming the power to the house, is 90% or better, right? With ducts outside of conditioned space. I can't find anything like that for high velocity systems. What high velocity systems seem to me is, I'm an architect, I don't like attics and crawl spaces, right? I want this kind of a shape. I need a system that defies the laws of physics. And so these people will sell it to me, right? That's what I think is happening.
They sold me.
Yeah, well, I mean, and test your system and come and talk about it, right? Like what are the thermal losses, right? Like what percentage of the consumed energy arrives at the house, right? Like, and
I have ideas on how to address it, and I went with a system that's a complete circle around the house basically, so it'll be self-balancing, and it'll make sure that each duct coming off of that is the same distance, so it self-balances too. And
But balanced is not the goal, right? Like I feel like and I don't mean any offense, right? I'm sorry, like, because I'm not always very good at this. I think that you've just been completely taken, because the needs of the building in that room and that room are completely different. So why would you want auto balancing?
It's residential.
This is residential. All my work is residential. Everything I build is this many CFM in this room and this many CFM in that room based on calculations.
What I'll do is vary the airflow based on.
And you should do everything you're saying and measure it.
They even have like dampers for the ducts,
Right.
basically to reduce airflow if needed and stuff.
Are
Right.
you using the Space Pack version?
Yeah.
of
Yeah.
the
And do you have?
I think there's an argument in low load homes for getting better mixing if you have small amount of,
Oh no, we can do that.
so you're trying to deliver only a few BTUs to each room but still mix it in well, and
I can do that
some
with traditional equipment.
right.
I mean, but if you did that, right? Like if what you had said to me was, you have a load calc for the house and you know that you have this many BTUs that you need to have in this room and it equates to this much airflow and you're going to match that,
Yeah.
that's awesome, dude. That's how you do it, right? And so then it's just, what does this delivery system work or not? But what you said is voodoo, right? Like I have I have loads that are not uniform, and I'm going to try to meet them in a uniform way, right? And so, but it's not too late if it's not all built, right? You could find out what the room loads are and see if you can get all that there.
I love the system so much, and I'm really stoked on giving it a crack. But the one thing that kind of throws me off.
But that's how we learn. So like, I don't want you to not do it, right? Like I just want you to.
I'm 100% doing it. Like I'm super jazzed on it. But
Right.
it's the high pressure system always trips me out too because that means it's a high static, high fan energy.
And it's going to be high fan energy.
Wait, but I've looked at this before because it's higher fan per CFM and then it's a lower CFM, so then it just cancels itself out.
Oh, okay.
Basically,
Right, and so the
it's
way
same
to,
fan.
so you would have to compare the systems that I would advocate for, which you can do, we can do all this with water, right? The refrigerant
Right.
still doesn't have to be in the house. You would have to do like fan energy per square foot or something, as opposed to fan energy per unit of airflow to compare house to house. Presuming that
Right.
both houses were held at some standard temperature, right? Like if you made them like laboratory, both these things are the same, and then we can measure a bunch of stuff. I would love to come to a talk that you were doing about how this works.
I'm going to show the team. I'm going to show everyone here when I get the system installed what it looks like, get proper feedback. But the interesting thing is there's a number of reasons for going with the system too. I live in a high water bungalow, and the aspirators are so cool. Like I love they're basically, they just inject air. Yeah.
Yeah.
And
I
it's
want
just
to hear it when
super
you
clean.
install.
Yeah.
And I've got the sound attenuators for it and everything. I went with, I nerded out with it. I went with a 5-ton system, but what I'll do is turn down the CFM pretty low, and it'll be interesting. It's a voyage of discovery. And
Well,
I've got a radiant floor coupled to it as well. So
Right on.
every winter, it'll be an
So that's your
experience.
cooling, and then you
Yeah,
have
yeah.
your heat here.
So measure a bunch of stuff and then let's talk about it.
Yeah.
Because like I'll just sound really negative if I talk about it now, right? Like, and I will say, man, that works if it works, right? Like I just have never found an example.
But there's some distinct disadvantages with it. Like, for example, this is high zone control. Mine is the whole house is a single zone.
I think whole house is single zone is awesome. I do it all the time, right? Why do I need zones? If the entire, like you walk in your house from outside, right? And it's 105, right? And you walk in your house and it's 72, whatever you wanted. And then everywhere you go is that. Why did I need zone control? My bills are low, the thing is quiet, the house is uniformly comfortable everywhere. Like I think that's a win. That's exactly what you should want.
Yeah.
I think we overcomplicate lots of stuff. And so I want to see if you can do it with that machine. I hope it works. I can't tell you how much I'd like to be wrong. So anyway, there was other questions. What?
Yeah, you're probably going to hit me for this question. How
I seem like that guy, don't I?
How about systems like Mr. Cool is selling, where they have the lights?
No.
And
I don't hate you. While I was doing this, in the back of my head was like, you have to figure out how to talk about that. So the very first Mr. Cool, I don't know if it was Mr. Cool, but Mr. Cool DIY style system that I looked at, it had plugged together refrigerant systems or refrigerant fittings that looked like they looked like compressed air fittings for a garage, for tire fittings, and they were plastic, right? And so I was like, I'm not even going to test these, right? I just cut them off, threw them out, and installed normal stuff. The next one I did, and you guys will like this because it's weird, is I forget what the brand is, but one of you is going to know. It's the mini split system with DIY refrigerant setups that can run direct DC or AC or both, right? So the solar company in town had me put one of those on their office. And it has some weird problems, like the wires that come from the solar panels to the mini split are like, they're not in conduit or anything. It's just direct DC wire, which you're not allowed to have exposed, just running down the side of the building and plugging into this machine. So there's some code questions about them. But it had a way better DIY refrigerant system. I looked at it and I was like, oh, I'm going to try this, right? It still relies on an O-ring, but that seems to be the way of the future. And the fittings were these heavy brass fittings and they had torque specs. And so I built it. I couldn't get it to hold vacuum the way that I normally would be able to hold vacuum. It held nitrogen without any problem, and I couldn't find any refrigerant leaking with the sniffers. And I used the really, really sensitive one that gives me false positives and this one, And I can't tell you how like nerve-wracking that moment is. Like if this thing goes off, I have like 6 hours of extra work to do at a minimum, right? And I can't test until the refrigerant's out. But it passed all of that stuff. It's like, all right, well, let's leave these. Like it's maybe a year from now, I'm gonna be like, oh, that sucks. I gotta go fix this thing. But it passed sort of 3 out of 4 tests, or 2 out of 3. And I have had systems where it held vacuum and it held nitrogen and the leak detector found a leak, right? So this was the opposite. It didn't hold vacuum perfectly. It wasn't really bad. It held nitrogen perfectly and it didn't show any leaks. So I don't know. I would really like it if that stuff worked. Because if that stuff works, then we could just stop having this conversation, right? Like just use this fitting, it solves the problem. And so, I don't know, maybe that'll happen. Right, well, I mean, they're not, I mean, there's going to be a bunch of other problems with those. And DIY, I'm not anti-DIY. I think it's great. Like people should do stuff for themselves as much as possible, or as much as they desire. But what I see in my neighborhood is a complete, like the DIY people have no understanding of air barriers, moisture barriers, and then they take the coil of excess refrigerant and they stuff it on the wall rack between the machine, the heat pump, and the wall. And so the airflow through the heat pump is impacted and you are never going to paint that wall again, right? Because there's literally a coil of stuff stuffed in there. And so there's maybe the next round of leakage is because those things don't seal when you unhook them, right? So the DIY person will just take the line set off, release the refrigerant, paint the house, put it back together and be like, oh shit, that didn't work, right? Because what do they know, right? And they're sort of not doing anything wrong, right? Like it's a DIY thing that didn't come with enough education. But I am really hopeful actually about that market segment. I actually think that the need to get people who really don't know what they're doing to be able to do this might save the people who are supposed to know what they're doing, right? Because the technological solution might win. I don't know.
What's the brand of that DC coupled mini split that we were talking about?
I don't remember, but I'll find it for you. It's a.
Those are cool ones, one too. Okay.
What did you know the answer?
Mr. Full has one for sure, but
Yeah, but that's not the DC coupled one. DC power, and I'm still a little like, why do we want this exactly? Right, like you have solar panels that make AC power. You can use that for like your fridge and your TV and your battery and everything else. Why do we want direct DC to the heat pump? I just think it's like neat and people are excited about it, but I think logically it falls apart. And maybe you come up with an example where I'm wrong and that'd be interesting.
Well,
You want it on
you
your
have-
sailboat?
yeah, like a container.
You want it on what?
My yacht?
Yeah, on a yacht, right? Or a trailer,
A trailer, yeah.
A trailer.
right? Yeah, so that kind of stuff.
In your yard, you just put a solar panel on it. Yeah.
What is this thing called? I know, I'll find the work scope. It'll be on the work scope. I'm still listening for questions.
You might just go.
I thought your comment about the non-split systems is really insightful.
Non-split, like,
The package units.
yeah, they're still, so they're split in the sense that the conditioning function and the heat pump function are split inside and outside of the house, right? And so package is really probably not what I should be saying. The refrigerant portion is packaged, right? But you're using water for split delivery.
Well, you don't have to use water, right? Like PTAX, like you have in your slide.
Right. And then there's all of those, and I had it listed on that slide, like the through wall mini splits now, or it's not a mini split. Everything is inside, like a hotel PTAC. I guess hotel PTAC's inside and outside. So it's just that everything's inside, and the air for the heat pump function is ducted to the unit, which is in the house, and then ducted back out. There's an Italian company that made them, and they're sort of like all the rage for multifamily housing. They have no plan for waterproofing at all. Like there's no plan for air barriers or moisture barriers or whether they're like the cladding, like they just pretended like none of that exists. You drill a hole through the building and you take a piece of plastic, like a plastic flexible cutting board, right? And you loop it and slide it into the hole and let it go, and it goes, right? And then you tape the seam, and that's your duct to outside. And then you take the grill that goes to outside, it's spring loaded and it folds in half, And so you fold it and you reach from inside the house outside, so you can be 10 stories in the air, and let it open up and pull it back into the end of this plastic thing, and you're done. Right? So like super fast. What's that? I don't know the brand. I haven't installed one, but Keith's company got a multifamily job, and Keith was really worried about, he really is always worried about doing bad work. And so he hired Gavin to spend 2 days figuring out how to retrofit a moisture barrier into the assembly, right? And then he trained his whole company how to do it the Gavin way. And so now they're installing these things with an existing flashing and moisture barrier. But the manufacturer didn't plan for that at all, right? So we'll solve the refrigerant problem and the buildings will all rot, right? So, I don't know. I'm still, anyway, just go ahead.
I noticed EG4 had one. Was it EG4?
EG4, that's the brand.
That's our battery,
Yeah. And I mean, in the solar company, they just want it because they sell solar, right? And so they take people outside, I think, and say, hey, check this out, right? There's no AC power to this at all.
Yeah.
And it has a little brain inside it, and it monitors the voltage from the solar panels, and it just won't let itself turn on if there's not adequate power. And so then once the solar panels are making enough, it'll run. And then when they stop making enough, it shuts itself off.
I mean, the other
You
nice
need
thing-
those.
It's exactly.
If you're not converting to AC, you're not creating the harmonics, which a lot of my people are really interested
Oh, sure.
in. So, I think that's great. That's really
See, now there, I knew you'd have a reason that I didn't.
Reason.
Thank you.
Yeah.
Yeah, that's cool. I never thought about that.
What's up?
So when you convert AC to DC and back again to create harmonics?
I was thinking AC, like air conditioning.
Oh, no, like AC power. Yeah.
Alternating current, direct
AC
current.
Yeah.
No, you need air conditioning that runs on DC power.
I need DC powered air conditioning.
Her house is really cool. You should visit her someday.
I want to visit her someday.
But there's not a lot of
We
AC
don't
power.
have indoor plumbing.
So harmonics?
You sort of do.
So normally in electricity you have a 60 hertz signal.
Yeah.
And harmonics are anything but the 60 hertz signal. And so when you're, a lot of these heat pump appliances create really bad harmonics that can be measured with an oscilloscope. So I did a talk on that at the Dry Climate Forum last year.
Wreck your other electronics in your house.
Yeah, and also health effects. So I'm a building biology and they radiate erratic electric signals through your walls. And some people are sensitive to that. So that's one of the things building biologists look for. But yeah, also it will wreck all of your intricate electric appliances.
And if you have an inverter from solar power, right, it's all transistors inside, and so you have the 50 hertz or 60 hertz frequency, and then you have 120, 240, and so on, all the multiples get in, and the higher frequency, the less power you have, but still, they're all in there.
Thank you.
It's always something.
Yeah. So that means that we wrap up at 8? Or in 10 minutes? Okay. I mean, I'm good. I'm just answering questions and happy to be here. So whatever you want.
Are we losing refrigerant from our car AC as well? Is it the
I
same
think the
thing?
cars are a lot like refrigerators, right? Like, we need to pull refrigerant out of Ashley's car so she can fix something, right? And it's probably not full anymore, but it's 300,000 miles in how many years? Right? Like
How many times did I bump into?
Oh yeah, right. Right. So like I think in cars, like yeah, it happens, but it's like it's a 20-year cycle or something.
Okay.
It's probably a sustainable cycle, and maybe I'm wrong about that, but my experience with cars is the air conditioning blows in like ancient jalopies, right? And I've only ever had to have a car system recharged one time. So I don't know.
It all depends on the car too. I have a 2003 Super Outback
And yours went flat?
and it recharged it 4 times.
Really?
Yeah.
See, and that's the crazy thing about like this whole mess, right? Like if you have to put refrigerant in, it leaks, right? Like it doesn't get consumed in any way, right? And so once, okay, great. Like I get a new customer, right? And I benchmark the system. I measure the airflow and I measure charge and I do all this stuff and I have all this data and it's low and I put some refrigerant in it. That's it, right? Like you don't get to pass go again. If you go back and it's missing refrigerant, it has a leak. And we then have to tell that homeowner, hey, look, you really got to fix this. and they all are going to try to say no because it's, you know, $2,000, $3,000, and putting refrigerant in is only $400 or $500. And so this is another Keith story. He's got a customer that calls him to do refrigerant repairs, and it's a condo complex. And so he'll go there, and there'll be like 3 systems that are flat. And he's got like, you know, like his procedure is like, I will not put refrigerant in. We are going to redo all of the connections, and we're gonna make it past our test procedure, and then we'll put refrigerant in it. And if you don't want us to do that, that's fine. Call somebody else, right? Like, so that's his standard wrap. And there's like 50 of these units. And so after he did like 10, he's like, well, can we just do all 50? Because they all are going to leak. And the management company, in their infinite wisdom, is like, no, maybe a couple of them won't, right? And so every year he goes back and does 4 or 5 more. And that's just how we're always avoiding the issue. So this, I really think that probably at the design and sort of large contracting, like big contracting companies, like I presume you guys are relatively large, like if we could shift our building stock to stuff that relied on a heat pump to change the temperature of water, we'd probably be a lot better off.
How do you distribute that water? And like, I mean, for heating, I understand, like just radiant for heating, that's good, but for cooling?
So cooling's a little bit harder. What's so awesome about refrigerant is it actually goes through phase change, as you probably know, right? So the amount of energy shifted by phase change is way, way higher than temperature change. Having said that, commercial buildings have been running on chillers forever, right? So they're just using chilled water for changing the temperature of the building and for dehumidification. If you get the water cold enough, you can dehumidify a building. And so it becomes a series of hot and cold water fan coils. So you can have a thing that looks just like that with really, really cold water blowing through it that will blow cold air. And they make them, right? And then you can have things that look like radiators, and you can actually do radiant floor and wall panel systems that do heating and cooling. They're more tricky because if you get condensation in the wrong place in that, it drips off and you're like, well, that's broken. If you get it in the wall, then you have mold. But they do make those systems, and they do work. They have dew point controls. Like if it were in a wall, they would embed dew point sensors in the drywall as a control strategy. And they tested a bunch of that in the Central Valley research homes. And so like it works here. There's a handful of examples, right? It's nowhere near as common, but it does work.
So are all heat pumps created equal? I mean, do you have favorites?
I use Fujitsu mostly because of avoidance of pain. So I went to Fujitsu because they had high airflow in their ducted systems, and we're in a dry climate. So high airflow in air conditioning means you do more sensible work and less removal of moisture. And so like when I design air conditioners, regardless of whether there's a heat pump involved, in our climate, I'm looking at 500, 600, 700 CFM per ton. I almost never pull off 700, but I get 500 to 600. Industry average airflow is like 280, something like that. Code requires 350, and a ton of code compliant past systems are operating under 350. We're bad at airflow. And so Fujitsu, on the average, is better at high airflow per unit of capacity. So they match our climate really well. And then once you're sort of embedded in a brand, there's a learning curve, and you develop relationships with tech reps and all that stuff. As soon as you change, you have to do all that stuff again. So high airflow per unit of capacity is what brought me there. Avoidance of pain is what kept me from leaving. So.
Did you say you're maybe considering that pain over again for a new company? I forget which one you said.
Oh, that's possible, but I have already forgotten.
He's thinking about dating around, but he hasn't decided.
I haven't decided with whom. Yeah, I think, well, and it's, I mean, if anything, it's the refrigerant. Like Mitsubishi, their stuff costs more and their airflow characteristics are worse, generally speaking. So I'm not in huge, and it's harder to buy their stuff. They don't want to sell to me. Like they're a pain in the butt for me. But they went to R454, so their refrigerant is better. And so I might consider them. And then, you know, like everybody else that I talked badly about in this talk today, like I have all kinds of pressure, right? Like I have to keep the guys busy. I have talks that I have to do on a schedule. Somebody's got to do the bookkeeping. And so researching a new company. It might be a year or two before I actually do it, just because of all of that reality.
What's R54 made out of?
I don't know. I know it's a new chemical, but I don't know what it is.
Well, it's
R32s,
blended, right?
yeah,
It's
they're
the
both a
future of the
blend. They're all blends.
Well,
I don't think it's not.
400s and 500s are blends.
Right. So R22 wasn't, the 400s and 500s are, but I don't know what the blend is.
I almost want to say it's R32 and propane, but I could be wrong.
Okay.
Not.
It could be.
Pentane?
Well, no, that'd be too easy. So R32 is already in existence and in use, just on a smaller scale, so they could step that up really quickly. R454 is actually new, and so I don't think R32 mixed with propane is new enough to have caused the refrigerant problem. Out of my depth, I could really be wrong about that, but I don't think that's going to be the answer.
Dichloromethane. Wait.
There you go, natural gas. We're not going to burn it anymore. We'll just use it as a refrigerant.
R32 and R1234YF.
Oh, that makes sense.
Perfect.
R1234YF is becoming really common too.
Is it? I haven't
In
been paying
automotive
attention.
use.
Okay, I knew it was in cars, and I'm not really a car guy.
We should really all introduce ourselves next time.
Maybe I didn't. Maybe I could have done that.
No, it's not here. It's not here.
We've never done it. It's actually a very novel idea. You should do it.
Anonymous building science and beer. Anyway, so some of you probably want to go home, so thank you so much, right? Again, and thanks for letting me come to your meeting. I'm glad I hope this felt useful. It's always something I find interesting to talk about.
Thank you for your work.
Yeah.
Oh.
He's the guy. I don't know if you guys know, but he is the guy. If you want HVAC installed, yeah, he's the guy.
Yeah, and I'm really, really trying not to be the guy anymore. I don't want to go anywhere that's far away, and I'm not doing anything where I don't charge a lot of money. So, like, it gets weird when you start to have a lot of success at something, right? Like, the demand will kill you, and then you have to sort of like violate your earlier sort of thought process about what fairness is in order to protect you. It's the whole thing gets really weird. So the only answer is to retire, right? So I'll give 5 years and I'm out, right? Like if I do this well.
Saying that though.
No. Pretty. I shifted it from targeting 60 to targeting 62, maybe 63 max. And it's really based on working backwards from how much money. This is, if you haven't thought about all this, you should really think about this. And I didn't for a really long time. But I think as a retired person, having an annual like discretionary income over $100,000 living in California is like a good minimum threshold. So if you start there and work backwards, you can answer that question.
That's for you. When we get there.
Right. So okay, but well, how old are you? How old are you now?
I'm 32.
32. Right. So that's great. I had I don't know, $30,000 saved when I was 32. I'm 57, and it's over $1 million, and I need it to be 3. Right? And so it probably won't be 3 when I'm 62, but I should be able to stop doing construction. Right? And if it's weird to talk about money for folks, I apologize, because it's weird for a lot of people. It really shouldn't be, right? Like no matter what you do, you can't have that money, right? Like it doesn't matter. And I can't have it either, right? Like it has to stay where it is so that someday I can retire. Because those of us that are self-employed, like nobody else is saving for us, right? And so whatever plan you make, right, that's how you answer that question. So 62, 63, I should be able to stop swinging a hammer. By 65, I should probably be able to do nothing. And maybe I'll miss, I don't know. Depends on a lot of things that are beyond my control.
Better find a hobby.
But if you figure out those answers now, I have plenty of hobbies. That's not a problem. Yeah, I really, really like airplanes, and
So,
Sorry.
we ran into this problem.
Yes.
With a subcontractor. So when you retire,
Yeah.
what happens if a client has an issue?
So
2 years after you retire or so.
the stuff that we built early in our career was so novel that that was really a problem. None of that stuff is broken, right? The stuff that I'm doing now is mini splits and, you know, pretty standard building enclosure details. And really, so anybody should be able to fix it. And some stuff is going to get screwed up.
So the example I'm bringing up is we're working with a client that had a roof leak. And could be two different causes. It could be the roofer didn't install it properly. The other is that they put in solar panels for their pool. And that company I'm not going to name, they came out. It's a huge company. They came out and they're kind of taking blame, but we still want to have the roof checked out. Because obviously they're drilling these screws in through the shingles that the roofer put down, possibly, and it's right at the peak of the roof. So it could be that water was coming up into the peak, and it didn't overlap the peak properly. Or the screws, because the water was coming through the screws. It's like it's a weird situation where it could be both. But the roofing company, he's retired. He's out.
Yeah. So I mean, if anybody really wanted to go down that road, you could drag that roofer back out because of the way the laws are in California. I think he's on the hook for 10 years for anything that you can show. But you have to show it was a. Right, you have to show that it was related to his workmanship for the 10 years to kick in. If it's just general warranty stuff, it's a year, right? And so like you guys, this company I presume has an insurance policy that like, so defects 10 years out are covered, right, by the insurance company. Little people like me are not gonna have that. And so I would just show up and I would show up and, you know, and I'm gonna keep one set of tools, right? And hopefully they'll get really dusty and I won't have to deal with them much. But I would just show up and figure it out. Because that's the easiest way to protect myself.
I mean, the guy that owned the roofing company is just like, I'm not jumping on roofs anymore.
Yeah, and I mean, and, you know, like at some point it's just not worth chasing them. If I'm really lucky, I'll just give my company to a couple of employees, and then it'll be their problem, right? Like I don't need to get paid for the company, right? If you want to keep doing this work, here's all the stuff. But you have to take all the phone calls, you know, you have to deal with all of that. That's essentially what happened when Gavin left. We paid him something, less than he wanted, more than I wanted to pay. So everybody loses, right? So that's how that kind of thing works. And then the rest is I don't call him. If somebody calls and says this thing that you and Gavin built is a total shit show, I just fix it, right? He doesn't have to deal. So I don't know. I don't know what the best answer is.
I'm just curious.
Yeah. No, it's things to think about. But at some point, like, you're all going to want to stop, right? Like, and so that happens. And it's weird, like, you think, like, I really dig this. And then, like, 10 years later, you're like, I am so over this. Right? And that happens really quickly. So, yeah, I don't know. I don't have the answers.
That was great. Thank you.
You're very, very welcome. Sure.